Let's now talk about Amazon Fraud Detector. This is a fully managed service that makes it easy to identify potentially fraudulent online activities. These can be things like payment fraud or also the creation of some kind of fake accounts. It uses machine learning models that are trained on lots of data on fraud detection. So this is based on many years of fraud detection expertise from Amazon. It uses machine learning models to do that. So these models are built on the fraud patterns that are learned from the fraud detection experience of Amazon, so that they know exactly how this works, and all of this data of a huge history actually. So here, this can be directly used, those pre-built models, or we can also customize them to fit them to our specific needs. So we can build those custom models, and they are now designed specifically on our own data and our own fraud detection requirements in our specific use case. It also provides real-time fraud detection. Of course, fraud detection is something that very commonly is needed in real time. So like this, businesses can directly and immediately take action when some suspicious activity is happening. So this is usually needed in real time to be able to immediately react to this. So this is something we of course should remember. Additionally, it also has quite easy integrations. So it integrates seamlessly with the existing applications. It supports lots of use cases, such as, for example, detecting fraudulent transactions during the checkout or preventing the creation of fake users. So here we have lots of different options available that we can also choose from. Then it also has this automated model training and deployment. So it automates this process of the training and the deploying of our machine learning models. And like this, it reduces the time and the effort that is needed to implement our own fraud detection system. So this is relatively automated and we can get access to this quite quickly. It is also pretty flexible and scalable. So it scales automatically depending on what level we have of traffic and activity, so that we can make sure that the fraud detection remains effective even if we have some kind of peak times. And of course, in the next lectures, we will also have some hands-on activity on this. So we will work on this and test Amazon Fraud Detector. But now let's briefly understand some of the important concepts, and we want to start quickly with the general workflow. So first, we start with data ingestion. So we provide our historical data. These can be things like past transactions or some user account details, some event logs, and all of this is now used by Amazon Fraud Detector to train the model. And then we of course have also feature engineering. So this is when we have the data available, we engineer the features. So Amazon Fraud Detector is automatically extracting here relevant features from the data. So these can be things like the transaction amount, user location, maybe some device type, all of the information that are needed and used by the model to identify the patterns so that they can find what could be a fraud or what could relate to this being a fraud or not. So all of those features are automatically extracted with Amazon Fraud Detector. And then afterwards, of course, the service trains the machine learning models on our data. And like this, it can learn to recognize the patterns and all of the anomalies that are associated with those fraudulent activities. And once the model is trained, it is now ready to be deployed to a production environment where it can now be used to analyze the real data, the new data. And this can also be done, if we want, on real time, so that we can immediately get those answers back. So those predictions, whether this is a fraud or not. So this is what we do with this deployed model, that we actually use it. So as new events like transactions or some account signups occur, Amazon Fraud Detector is evaluating them against the trained model, and it assigns a fraud score. So this is indicating the chances, the likelihood of the fraud. So this is a confidence score, how much confidence there is that this is a fraud or not. And then the organization can use these scores to maybe trigger some kind of an action, maybe some kind of flagging transactions for manual review. It can also maybe block them entirely. So if this is a very suspicious activity, it could be blocked, or maybe the user could be notified that there's some kind of strange thing going on that is maybe indicative of some fraud or something that might happen. So let's quickly talk about what we can achieve with Fraud Detector. Of course, reduced fraud losses. This means by accurately identifying some of the fraudulent activities, businesses can reduce the financial losses that are associated with the frauds. This is obvious. And it also offers some improved customer experience. Of course, real-time fraud detection will also help in providing a smoother and more secure experience for genuine customers that we, of course, would like to retain as an organization. And of course, it provides also operational efficiency. So this means that automated fraud detection will reduce the need for manual review. So we can save time and we can save resources. And also this service can handle quite a high volume of transactions. So we are not compromising on the detection accuracy when we have some higher volumes of transactions. So we can remain operationally efficient. And in regards to the use cases, let's briefly also mention some of the important ones. Of course, e-commerce transactions. So it can detect and prevent also here some fraudulent purchases, maybe some kind of payment fraud or some account takeovers as well. Additionally, it also is quite useful in account registration processes. Here, it can identify fake accounts and prevent also an account creation that would be a fraud. So some fraudulent account creation can also be recognized in here. And then also lending applications. Fraud Detector can also assess the risk of a fraud in some loan applications and loan approvals. And finally, of course, in online gaming, there it can also detect and prevent in-game frauds and some cheating activities. So this is, of course, another use case. All right, so that's it for Amazon Fraud Detector with the concepts. And now let's have a look at this with some hands-on activities in AWS as well. In the next few lectures, we want to talk a little bit about Amazon Fraud Detector, which can be used to identify potentially fraudulent activities. This can be, for example, some banking transactions, or maybe some credit card usages, or maybe some new account that is being set up, or even things like a product review. All of those use cases we can implement using Amazon Fraud Detector. So how this works is, first of all, we can see those steps in here and we will go through them step by step. So first of all, we can explore the data model and set up our business use case. This is very quick and very easy. Afterwards, we can define a so-called event that we want to evaluate for fraud. This is an event type that we create. So here, for example, this can be, like in our case, an online transaction that we want to evaluate, and we can store this with associated variables. So we have a data set that we can use to train the model, and this makes up our event. Additionally, after we have done this, we can of course train our model. So here we can use this data set, so some historical data set, to train our model. We can upload this and then we select a model type that we want to use for this training, and then Amazon will go through all of the different steps to set up a model for us, and this includes inspecting the data set, enriching the data set. For example, there are some feature engineering going on. So this is all behind the scenes. This means we have some additional fields, maybe the data is being modified maybe so that it fits the model, and then it selects an algorithm and tunes the model. So this can take quite a while until this model is then trained for our specific use case on our historic data set. And of course, then once we have done this, we can set up our own custom rules to decide when we want to say that this is, for example, a fraudulent activity. And then we can use this result, so we can feed in real-time data. We can, for example, use those APIs, and then we can also stream in data. We can build our application and use this detector API. So essentially the detector is this what we are using in the end to determine whether this is fraudulent or whether this is something else. So we will basically for this detector use our model and add some so-called rules. So these are basically thresholds that we can use to decide when this should be a, for example, high risk or when this is fraudulent. So we can categorize this using those rules. But now this is how it works. And of course, let's implement this now in practice step by step. So to do this, we can just again search fraud detector. We will find it in here. And then we can click here on get started. So step number 1 is to create a data use case. So step number 1 is to just explore some data models for our use case. In this case, we will choose online transaction fraud, and in here we have a few different model insights. So these are some of the fields that we should have, and then based on this we can now set up our data. So this is just our use case, and then based on this we can continue with the next step. So here we choose online transaction fraud, but note that we have also additional use cases and also some custom fraud model. So here we see what are the insights and what this is used for. But we will just be okay with this one. And afterwards, we can now start with the first real creation of our resources. So this will be the event type. I have already mentioned that the event type is essentially defining the structure for the event that we will send into our model. So this is used for the training of the model and also predicting the outcome. So this is essentially our data set structure. And here we want to set this up. So we need to set this up and we call it, let's say, transaction event. We can give a description if we want. And then here we have a so-called entity. So an entity is essentially who is performing this event. If we have a transaction, in our case, who is performing the transaction. So we could say this is, for example, a customer, or this could be the merchant that is performing the transaction. In our case, we want to create a new entity, and it will be, in our case, actually the customer. So we just type in here the customer, we create this entity, and here we see also this represents who is performing the event. For example, here even the customer is mentioned. This is what we will also use in our case. And now we want to create some variables because each event type is made up by a collection of variables. So these are things that are associated with this event. For example, a timestamp, a customer ID, or maybe a transaction amount. All of those variables are usually part then in our data set, and this is what defines our event. So here we have two methods of defining the variables. We can either select them from a list if we have already set this up, or we can also select them from our training data set. This is what we will be using so that we can make this a bit faster, because in our case, we will use this data set in here. So this is our transactions. It will look like this. And we can see that here we have things like the event timestamp, the credit card number, the merchant, the category, and so on and so forth, some address data. All of this is part of our data set. And this is now what we want to use. So therefore, we need to have also permission to access this data set that is part of an S3 bucket. So therefore, before we assign also the role, let's actually set up this S3 bucket. So let's navigate to S3. And in here, we want to create a bucket. And we can call this let's call it fraud detector. And then maybe some kind of a combination of some numbers or characters so that this bucket is unique. Here we can leave all of those default settings. We can create the bucket. And of course, now we can open it and we can open it and we can also upload this data. So this is our training data. We can click here on upload, and afterwards we use this train data set. We drag it in here. This is, I think, around 13 megabytes. We upload it. And then once we have done this, this takes maybe a second or so, we can open this actually directly. And here we will see this is the file and we want to copy this URI. So this is the location of the file, or yeah, the exact path. And this is what we want to use in our variable here. So we can say, once we have selected a role, so now we create a new role for us, and here we want to have access. So we can actually directly paste this, but we only want to have the bucket name itself. So here, this role then also has access to this bucket to access the data here. And I will say create role. Here we have created now this role. This is our data access role. And now we can paste in the full location of the data. I can click here on upload, and then it will be uploaded into FraudDetector. And we can already see these are now the variables. Here we can now go step by step. We will choose now the associated variable types. This is now part of the model. So here we can, for example, say transaction ID. This is, for example, maybe some kind of a user order ID, something like this. And then we have here the credit card number. So maybe we also have something like this. Let me check. Here we have some payment card number. This is what we can use. And then here we have a few more things. For example, we have the category. Let's search for maybe something like category. We have product category. This is fine. And also we have some custom categories that can also be used if this is not available here, what we are using. So for example, for the merchant, we can say this is maybe a custom category. So here, this is some custom categorical value. In our case, here we have the amount. So we can choose the maybe total order price, something like this. Here we have first name and last name. Let's just use the name in here. We can also use the second one as the name as well. Shipping address, gender. Maybe this is something like another category. So just custom categorical. Then we have the street. We can search again for address. And this is address line 1. We have the city, shipping address, and yeah, it's not so important in our case what we are choosing here exactly. So I just make sure that this is roughly correct. So let me use here state, shipping address. We have the zip code. I'm sure we also have something like this. So we use that as well. Then we have latitude, longitude, all of this we don't need. Maybe the job we can have as some kind of a categorical value. So custom categorical. And then here, this is date of birth. We also don't need it. Transaction number, let's also leave that. Yeah, we want to just make it a bit, we just want to keep it basic. So we will also just remove the remaining variables. And now we also need to choose the labels. The labels are used to categorize the events as either fraudulent or legitimate. So here we can have a look into our data set again. We can see that there is the event label as well. And this is basically 0 or 1. So here, of course, most of them are okay. But if it is fraudulent, this is the labeled data. This means for this training data, we already know that here we could see 1 actually. So this was actually a fraudulent transaction. And now we can use this to, just train the model. So the model knows this is how a fraudulent transaction could look like. So here we want to say that this is something like 1 and 0. So the label name is 1. And here we can add a description. We can say this is maybe fraudulent, and we can create this label. Then we can add a new one, and this could be the 0. And here we could say this is maybe something like legit. So we create it, and then we have those two labels, and now they are used to find out whether this is a fraud or whether this is legitimate. And then we are ready to have this created. And now, of course, once we have done this, we can go ahead and build our first model. So how this works, we now want to have a closer look at in the next lecture. Now that we have set up our event type and also the associated variables, we can start to build our first model. We can either click here directly on build a model, or we can also just from this left navigation navigate to the models, and in here we can also add our own first model in this case. So I can click here on add your first model, and we can give it a name. For example, we can say this is transactions model, something like this. And we can now choose the model type. We can leave it actually at online fraud detection. We could also use transaction fraud insights, but in this case, we must first store a data set in here, and therefore we will just use the S3 file. So we will choose it in here. Otherwise, we would have to first upload some historical event data and store it in our event type. So therefore, in our case, we just can leave it at online fraud insights. Here we have a big variety of online fraud risks, so we can easily use this model type and we will get good results. Here we can see a little bit of a description of this model type as well, and we can choose our event type. And now in here we need to have the historical event data, as I said, and in this case we can, as I have mentioned with this model type, also use data that is stored in S3 instead of data that is stored in Amazon Fraud Detector. So therefore, in this case, we can just create again a role that is used to access this data set. Here we can use an existing role if we have one of those data access roles created before. Otherwise, if you don't see one with data access role, just click here on create new role, and then in here basically you just also give the bucket name. So we can paste it in here. We just need to make sure that this is the correct bucket, and then we can paste it in here, and like this we create this role. So now we have just created this new role as well, and we can provide also here the data location. So this will be now the exact location to our data set that we use for the training. So this is the historical data where we have also the label included. So which transaction was actually a fraud and which one was legit. So I copy this URI. This is exactly pointing to our data set, and I can now paste it into this location. And then we can just click on next. And in here we can now define the model inputs. So this will be all of the variables here per default selected from our historical data set. So we use all of this. And we can, in this case, also we have to specify which are actually the fraud and which are the legitimate labels. So we have created those labels before, but now we must also define which are actually the frauds. So here one is representing in our data set that this is a fraud. Here we can see this in our data set as well. For example, this one is a fraud. So therefore in the column event label, we have the value of 1. So we can see this one, for example, is a fraud event. And this was why it is classified or labeled here with a 1. And this is what we have to specify in here. So legitimate labels means it is a 0 in our data set. So we have created those labels before, and now we just classifies them to categorize those events. And also the unlabeled events, we can just ignore them. So we will anyways won't have any in our data set. So this is fine. And yeah, if most of them are actually labeled, we can just ignore the unlabeled ones, because then the model, it will be trained anyways well, and we don't need to do something specific with those unlabeled events. So in this case, we can leave it and we can go to next. And in here, we can now review everything again, and all of this looks good. We can therefore click on create and train model, and this will now create our model. And additionally, it will also create one model version. We can see the status is currently training, and then this takes about maybe an hour or so until this is completed. And then once this is completed, we see that this is ready to be deployed. So we can deploy a version of a model, and then we can use it in the so-called detector. So every new training of this model setup, when we have maybe some new data, will be then a new model version, and it can be used to deploy it and then use it for predictions in our so-called detector. But now we will just wait until this is completed. This takes about an hour or so. And then once this has been completed in the next lecture, we will go ahead and use this model version, deploy it, and then use it in our detector to now make predictions on our transactions. Now, after about half an hour, this model has been trained and we now have this model version. So a model version is a trained model with a specific set of historical data. And of course, when we do this again, maybe 1 week later, we can also have another version. And we are then essentially using those versions to make the predictions for new data. And this model version, to make the predictions, we first have to deploy it, and then we can use it in the detector that we also create to make our predictions. And at the detectors, we will have a look at in just a second as well. But before this, we want to have a look at the evaluation of the model. So we want to understand this a little bit better, because we already can see this performance kind of summarized by this AUC, which stands for area under the curve. So let's understand this in a second in a bit more detail. So we click on this version, and in here we can see this model performance. Here we can also see this AUC, which stands for area under the curve. And this summarizes those so-called true positive rate and the false positive rate across all possible model score thresholds. So what does that mean? We will see also and understand a little bit better with those two graphics. Essentially, a high performing model has a score close to 1 and a low performing model has a score below 0.5. So ours is actually quite nice. We can also change to the table view, and in here we can see that our performance of our model is actually high with an area under the curve score of 0.94. So here we have this explanation and some explanation of what this exactly means. So let's switch back actually to the chart to understand what this exactly means, this area under the curve, and then also understand this confusion matrix here. So first of all, in this graph, this is the score distribution. We have in our model, when our model makes a prediction on each transaction, so for example, in our data set, each of our records, in here, for example, this one, let's say the model gets now this record and it has to decide whether this is a fraud or legitimate. And it will not say yes or no directly, but it will give a score. So a confidence or a probability with that the model thinks that this is a fraud or not. And the closer this is to 1000 essentially, the more certain the model is that this is actually a fraud. And the closer it is to 0, the more certain the model is that this is a legitimate transaction. So now we can decide ourselves where we want to make the threshold to predict that this is labeled as a fraud. So of course, this depends on our use case. And here we can see now the results depending on how we set this threshold. So in here, if we set it to 500, which it is set currently in here, we have 91.7% of all of the fraud events catched. So this is what we can see in here. And this is the true positive rate. So we can see true positive that are actually frauds. We have recognized them, and this is 91%. So 91% of all of the frauds we have detected. However, we have actually also some false negatives. This means that we have also 9% that were actually frauds. So this is this one. This were actually a fraud, but we have predicted them to be legitimate. So of course, now if we say we want to classify this a bit earlier, maybe somewhere here, let's make it as an example, we can see in this case, with this threshold of just 105, we would catch more of those. So this false negative rate, the one that we don't catch, is getting lower. And with that, our true positive rate is increasing. But unfortunately, if we say it like this, we have lots of actually legitimate transactions that we have categorized still as fraud. So with this threshold, all of those would be categorized as fraud. And you can see all of those green ones, they are now all false positives. So we have predicted them to be positive, which means it's a fraud, but they were actually falsely predicted as a fraud. So with that, we can see that we would have lots of transactions that are actually flagged as a fraud, but then it turns out they are actually not a fraud. So here, depending on how we would like to have it, we can see what is now a good true positive rate with still a acceptable false positive rate. So here we just have to adjust how we want to have it in our use case. And here we can simulate basically how this would turn out. I think in our case, I have done this before actually, the result was even better. So maybe depending on your situation, how this is trained in your case, maybe you get even better results. Because I think this could be even better here. But yeah, it is still an acceptable result. And we now can also understand this area under the curve. So now essentially, if we go through all of those possible scores, we get the AUC, because this is now just summarizing all of those true positives and false positives across all possible model score thresholds. So this was a quick introduction into understanding this score distribution and the confusion matrix. And additionally, under advanced metrics, we can also see the ROC curve. So here we have the relationship essentially between the true positive rate and the false positive rate. Because we can see now, depending on how we set the threshold, one of them is increasing. Of course, we want to have a high true positive rate, but along with that also the false positive rate is also increasing, and we don't like this. So with this, if we set it to a high value, we can see then, unfortunately, the true positive rate is decreasing, but luckily also the false positive rate is also decreasing. So here we have this relationship visualized with the true positive and the false positive rate. So here, of course, both will decrease if we set the threshold to a lower value. So like this, we can maybe figure out what is a good combination of those values. For example, maybe somewhere around here or maybe around here, we get still an acceptable false positive rate, but a pretty good true positive rate. This helps us to set a meaningful threshold in our model. So maybe we want to set it somewhere around here or maybe around here. Let's maybe put it somewhere so we can see it moves. And maybe this would be a good way of setting it in our case. So we can set it somewhere around here. This is what we could do in our case. Lastly, we also have the model variable importance. This is now showing us how important this value was to predict the value. So how much of an effect this had on whether this is a fraud transaction or whether this is a legitimate transaction. For example, we can see the order price is actually quite important to determine whether this is a fraud or not. However, for example, the payment card number, the credit card number, or the street is not really that important. So we can't really use that in our model to make a conclusion about whether this is a fraud or not. Very different though with the amount and, for example, also the product category. Here we can see that there seems to be a correlation between the product category and whether this is a fraud or not. So here we have this understanding to just get more insights into the data, to what variable is contributing to our model performance. But now, of course, we have this model evaluated, we can see the threshold, and now we want to deploy this and make predictions with this model. And how this works, we now have a look at in the next lecture. Let's have a look now at how we can deploy our model and then also how we can use it for predictions in a detector. First of all, we have this model version selected, so I can go back to the model, and in here we want to now deploy it. So we have to do this always with a version. We could use this model to train another version, or we want to deploy an existing version. So this one here is trained and therefore the status is ready to be deployed. So we can select this version, and in here we can now say that we want to deploy this model. We have to be careful that, of course, now deploying this model, we will make it available to the detectors. We can use it for real-time fraud predictions, and of course we will be charged by the hour for on-demand hosting of our deployed model. So we have to be aware of this. Of course, we have part of the free trial, but of course we should also make sure that we are afterwards cleaning up our resources. This means we delete all of those resources that we have created to make sure that we are not incurring any unnecessary cost here. So therefore we will go ahead and deploy this model. This will take a little while until this is being deployed. And here we see this is currently initiated, and under our model we can go in, and in here we see that the status of this version is currently deploying. So after about a couple of minutes, so after about 10 minutes or so, we will be back, and then we can use it in a detector. And after about 10 more minutes, the status has changed to active of this model version. So we have successfully deployed our model version. And now what we can do is we can create a detector and use this model version. So therefore, let's navigate to the detectors, and in here we can create a detector. So we can see now in those steps, we have gone through all of those steps. We have built a machine learning model. We have built the event data set, and then now using this model version, we can add some rules. So this is basically the threshold for the score, so that we can evaluate our events and generate predictions, so outcomes based on the data that we are getting. So this is what we want to do. So therefore we will say either build detector, or we can also create a detector from here. And we can say in this case, for example, just transaction detector, something like this. Very simple. And event type, we choose our transaction event, and then we can just click on next. Here we can select our model version. So I select this model and the version that we have successfully deployed. We add this as a model, and in here we see the model output variable is called transaction model inside score. This is what we need to remember, and in here we can just check this box. So we add this as a model, we go to next, and now we can define those rules that we talked about. So this is an important part of our detector, because this is using now this model score to determine whether, based on our rule, this should be a classification such as, for example, high risk or low risk, or maybe fraud or legitimate. We can define our own expressions in here, and here we can reference those variables to create a condition on when we want to choose which categorization. For example, if I just type in this $sign, I can see the variables, and in here we have also this transaction model inside score. And this is now where we can create a very simple expression. So for example, if this is less than, for example, 400, we can say that the outcome, so here we can also define these outcomes, we can say this should be the outcome, maybe low risk, something like this. And now if we have another rule, of course we should first finish our rule actually. So we can say something like this is maybe low risk, and then we can add this. So I can say this rule should be added, and now we want to add another rule. So here we can see this is the expression, and we want to add another one. So we can say, in this case, we can create a new one, because we can create multiple of those. And here we can say this is maybe, let's say, something like this. So here we can, for example, say this is once the score is more than, let's say, 800. So here we can scroll down to get the inside score, and we can say once this is maybe more than, let's say, 900, we say that this is in our case another outcome. So we can say this is the outcome, maybe high risk. And then we can save this as an outcome. And again, we can add this as a rule. So I say add rule. And now we can add another rule. So the last one we also add. So here we again create a new one. And we say now this is maybe medium risk. Medium risk. So maybe this is uncertain or something, or yeah, we don't have really a high risk. So here we can say something like in between. So we have the inside score is maybe larger than, let's say, 400, but it is also less than, so let's actually make it like this, between 400 and maybe 900. So we could do it like this. 400 is larger than 400. And then we can combine this with just something like and. And here we can have another condition. So in this case, we can say that it should be larger. So it should be less than 900 to be still the medium risk. So we can define it like this. And in this case, we have a new outcome, and this will be medium risk. Save this as an outcome, and we can add this as a rule as well. So now we have our three rules, and this gives us different outcomes. So we will have either one of those three outcomes for every data record that is input here. So we can go on next. And now we can also, sometimes we have some overlapping. So maybe we have, in our case, actually, we have 400, but here we have more than 900, and here we have in between. So sometimes we have that they overlap. So therefore, if multiple of them match, we can define which one should be the most important one. So we can have this order. I can say this should be the first one or the second one. So yeah, in our case, it doesn't really make a difference, but we can also choose that all of those outcomes, so we can say that all of those matched outcomes will be also added. But in our case, we can just leave it also at first matched. This is absolutely fine. And we can then click on next. And now we can create this detector. And of course, we can now use this as an API. And of course, we can now use that, and in here, we can also test it. So we can enter some values. For example, I can just use some of our values actually from our data set. And in here, I'm using the test data set. So this is actually one that we have not used in the training data. So let's see if we can use some of this data. I will just go ahead and paste some of those values. So I find, for example, the grocery product category. We have some of the values we want to add. For example, the amount we might want to add, we can paste it in here. And some of the additional values we could fill in, but we can also leave them empty. So we get a faster result. So let's see if we run the test. We can see in this case, it actually predicted high risk, which is actually correct. So here the score is 946, which is higher than 600. So in alignment with our rule, we have that this is a high risk outcome. And indeed, actually, this is, in our case, I have chosen here one where this is actually a fraudulent transaction. So this was pretty correct in this case. So with this, because I know these two variables are actually the most important ones. So with this combination, we could already have something that is maybe relatively accurate. And indeed, we got here a pretty good result. So this is now the detector that can be actually used to make predictions. So we just have to feed it some data. We can also do some batch predictions. So we can have some data here uploaded. So we have some data here being in a location, in a bucket, for example, or of course, we can also use it in an application, and we can also see the past history of the results. So this is the detector that is actually being used to make our predictions. All right. Hope it was helpful, and see you in the next lecture. So before we finish this, let's also make sure that we are deleting all of the resources that we have set up. So we need to do this in a specific order. So for example, if I try to delete this variable, I can say this is something that I would like to delete. I can confirm it by just typing the name. And then I see this won't work because we have to first remove the variable from the event type. In the same way, I can also not delete, for example, our detector. So if I say if I want to delete the model, to be more precise, I can not delete it because there is a version included. So if I try to do that, I can try to delete that, but then I see it won't work because it has a version and we first need to delete the version. If we try to delete the version, it says it is being used in a detector. So we first have to remove it or delete the detector. This one also has to be undeployed first, so let's do that. So I try to undeploy the model version, but we can't do it because here this is part of a detector version. So this is why we should start actually with the detector. In this case, we have to delete the detector. This works. So we can type in this name of this detector and then we can delete it. And in here, we actually first have to delete the version. So let's open this version. And in here, we can delete this version. So always we have to delete anywhere where there are some versions, first the version. So this has been deleted. And then we can also delete now this entire transaction detector. So let's make sure we have it exactly correct so we can delete it. And here we can still not delete it because there are some rules associated with it. So we can see these are those rules. So we can also go ahead and first of all delete the rules. So we can select it. And in here we have this option of deleting this rule version. So let's go ahead and delete it. We delete this version. Now we can go back to the next one and we can do this also for the other ones. So we just paste in this same version of the rule. So here we can also do that for the last one. Action, delete rule version. We copy it and then again we paste it so we can delete this version. And now let's try again to delete this detector. We try to do that. We can type in again the name, delete it, and then it has been deleted. So now as a next step, what we can do is we can now go to the model because now we might think that we can delete it. So let's go into this model. Again, here we have to start with the version. So now let's try to undeploy this model version. We can just type in undeploy. And then we can see in this case it works. And now we can try to delete it. So we again have to copy the name. We delete the model version. And in this case, we still have to wait probably a few seconds until we can delete this. So let's go back to our models. And in here we can see the status is still undeploying. So we have to wait a little bit until this is undeployed. And then we can actually delete this version, after which we can then delete the model. So now we see that this is again ready to be deployed. And now we can go ahead and try to delete this version again. So I will open it and in here I can say delete. So I will again just copy and paste the name. And then select delete model version. And now the model doesn't have any versions anymore, so we can actually delete the model. So we copy it and paste it to delete the model. Now we see the model has been deleted. So what is left is now a few things. So we have, for example, the variables. We can delete all of those variables as well. And also the labels we can delete. Let's maybe start with them. It's a bit easier. So we delete them. We just type in the name. And we can see in this case we can't use it because we have to move it from the event type. And the same is actually also true for the variables. If we try to delete them, again, this doesn't work. So I try to do that. Then I will see it won't work because it is actually still part of the event type and we need to remove it from the event type. So therefore, let's go to the event type. Let me open this. And if we are trying to delete the event type, let me just copy again here this name. We will see that also this doesn't work because it contains one or more events. So we have to first remove all of those variables. I will delete all of them step by step. So we can also fast forward in this one. And then we can see this doesn't work because it contains one or more events. So we have to remove those events first. We can do that by navigating to stored events. And in here we can delete the stored events. So I will just type in this one in here. I have to remove the beginning, then I can delete it. And now we are ready to delete this event. So here I will go now to delete event type. We will be able to paste it just like this. And then I say delete event type, and now it has been deleted. Now we can also go ahead and delete all of those outcomes because they are not part of any event anymore. So I can say delete high risk. So this is just to clean up all of our resources. Still, now this won't incur any cost anymore, but still it is good to delete all of those remaining resources. And then after we have deleted the outcomes, we can also delete those labels. I just open them and then we can simply delete all of them very quickly. And lastly, we can also delete all of those variables. We have to delete them, unfortunately, all one by one. So I will also fast forward in this one. And then once we have deleted all of the variables, we have finally cleaned up all of our resources. So this is just helpful to make sure that we are not incurring any cost. And of course, this is a best practice that when we don't need anything anymore, that we are also deleting it. All right.